So in this video we will discuss how we can locate any place by using Google Earth, then over that place or how we can draw the profile, alignment, and how we can measure the area, cut and fill volume, sorry. So let's see. I have opened the Google Earth Pro and I have searched the area in Sakhar. Now in the Sakhar I will mark the area in which I am interested. So let me search an area. Okay, that is the area. Now go to the add polygon tool, then add polygon, select on it, then see the cursor has become a square now. First give the name to that polygon, then click the point through the cursor. Click first, second, then third, then this fourth. Now you can also drag the point if you are taking more area. Drag it and drag it. Okay, so this is the whole area on which I am interested. Then okay, now it's appear in the palette here, places. Then just right click on it and go to save place as. Now you have the option to save the file in KMZ format. So by default you have two format. I am saving it in KMZ format. Now open the Global Mapper software. Now in the Global Mapper, open the data file which we have saved, place in Sakhar. Now look at this thing. Your whatever you have selected there is available in Global Mapper now. And go to the tool and first configure that thing. Go to the tool, then go to the configure. Now since this Sakhar area is in Pakistan and it is the part of UTM zone 42, so we have to select the UTM zone. Go and select the UTM so that it will align with its zone coordinates. Apply OK. So it's now aligned with the UTM zone coordinates. Then go to that globe symbol, click on it. Now this is a window from which you can download the digital elevation model. Click connect. See, the elevation model is downloaded here and it is also appear in the left palette. Go to that thing and select it, right click on it, and then export that layer, the DEM by layer and the DEM. Now this is click here, selected here, then press OK. So you are saving that DEM, and again OK, then OK, then give name to it. You can also interpolate it. If there are some data points which are missing, you can check on the interpolation. You will have to set the units. Let me set the unit to the meters. I have already given the name, then click OK. By clicking OK, it will give me an option to save the file. Now I am saving that file by giving the name here also. So it's saved now. Now I will have to open the AutoCAD Civil 3D. So go to AutoCAD Civil 3D, open it, then go to the surface in AutoCAD Civil 3D. At the left, go to the surface in AutoCAD Civil 3D. Then give the name to the surface. In the tool space, here is the option surface. Give name to your surface. This is the third option. Just right click on it and give name. I have written the Sakhar, place the name. Then see, now there is plus button which is visible here. Now define that surface. Go to the define surface and then DEM file. Right click on it, add Then just click on the box and find that Sakhar Place DEM and OK it. So the information is visible here now. Then OK. So where is it? We have to click on the navigation tool. Click on the top. Look at here. Your surface is formed in the form of a contour map. Look at here. Basically, the Civil 3D generates the surface by default in the form of contours. So you have the contour. Now what we have to do? We have to draw a rectangle. Let me show you. I am drawing a rectangle to find the cut and fill area between the proposed surface and the natural surface. So currently this polygon has the elevation of 58 and my units are in meter. So let me convert this rectangle into a surface by again going to the surface tool and create surface. Then let me give it a name, proposed surface. Then OK. Then now again go to the proposed surface option. Now again I have to define that proposed surface by using break lines. Then add, then give a name, then OK, then select that rectangle, then press OK. Now you see the color is changed, which is same like the color of the existing surface. So this is another surface. Now we have to calculate the cut and fill between that surface which has the elevation value 58 meter and our base surface. So what we will do, we will go to the surface, then go to the utilities in the menu bar, then volume. In the volume you have this create new volume surface. Click on it, then just write the name of it, volume. Then it asked me, okay, what is the base surface? So define your base surface as the surface which you have imported. Then your proposed surface is the surface which you have drawn in AutoCAD Civil 3D by yourself, proposed surface, then OK, then OK. So look at here, OK. So it has given us the cut and fill volume and the quantity with the bar, what is the net cut and net fill. So what we can do with this, we can generate a report and we also insert that summary into the model space. So let me insert that summary here. So you can see the cut, fill, summary is shown here between two surfaces. This we do usually when we have a plot and we have to flat that plot to make the building over that plot, or to make a garden or anything over that plot. So this we have done. This is the first task we have done in AutoCAD Civil. Let me delete that proposed surface and move to another task, which is basically the alignment. I will just click on it and press delete on the keyboard. Then go to the alignment, which is given in the toolbar. Go to the alignment tool, here alignment creation tools. Then you have to give the name to the alignment. This is the name to the alignment. Then there is a thing how you will define the alignment. We are defining the alignment by the center line. Here the alignment means horizontal alignment, not the vertical alignment. Then you can also set the design criteria. Currently it is selected the 100 km/h is the design speed. You can also select the H2 design criteria, then click OK. So there is another window, alignment layout tool. So the first option, which is tangent with curve, you have to select that option. Second option, tangent with curve. Then click on the first point, then you can move anywhere on the surface and it will become a alignment path. So let's draw at here. So see, it will drawn with the curve. So see, look at here, this is the curve, this is our whole alignment, and this alignment also have the curve, not only the tangent but also have the curve. By default you can automatically generate the curve by using the alignment. You don't need to calculate the curve, it is automatically generated. That's how you will define the alignment over a surface and generate the alignment with curves in the AutoCAD Civil 3D. So let me close it. Then our next task is to define the profile. So I have selected the option create profile from the surface. Now we have one alignment which is AL1, and the surface is, we have only one surface, so I am adding that surface. Then go to the draw a profile. So this is the thing, then draw profile. So it gave me another option, create profile view. So I can set the setting here. Currently I am putting it by default, going with the default setting. Then you can change the settings here, then create. Before moving to, let me check the last till last. Now create profile view. So this is the profile we have created. Okay, look at here, at the bottom we have the station, and at the left we have the elevation, and this is our profile which is selected here. This is basically the profile of alignment 1 which we have marked on our surface. Okay, so this is how you can draw the profile in AutoCAD Civil 3D. Now over this profile we have to generate our vertical alignment, or the alignment which have the vertical curve. So we will again go to the profile option. So look at me, let's see, this is the profile option, then create profile by layout. So this is my profile. Over that I have to make another profile. So AL1 is the base profile. I am generating our new profile which is basically the proposed one. So let's write it proposed, then click new proposed, then click OK new. So it again give me an option, draw with tangent or draw with tangent and curve. So I am drawing it with tangent. Now this time it will draw vertical curve. Since I am drawing it on the profile, so it will draw vertical curve, not the horizontal curve. I am setting a new alignment in profile view, so it will generate vertical curve. So let me finish it. This point, you can mark any point as per your design criteria, which is basically normally the slopes or the side distances. These are the key factors which we consider while designing the horizontal and vertical curve. Or cut and fill, we also need to balance the cut and fill. Let me show you here how we have drawn the vertical profile. So look at here, this blue line is basically showing the proposed vertical profile which is available with the curve. Look at here, this is the vertical curve, all PVI, BVC and EVC are given. This is the second vertical curve, then this is the third one, this is the fourth one, and the fifth one. You can draw multiple curve along the alignment, whichever you need it. You can draw it by just clicking on the profile. So let me make it a more visible. So I will have to just right click on it. Okay, just right click on it, then go to the edit profile view style. Here we have the tab grid. Then in the grid, okay, now this basically, okay, the grid, horizontal grid, you have to check it so the grid get off, then apply, then okay. So now look at here, this is blue line, it's clearly shown here, which is basically my new proposed profile, and the line which with the grids is basically my existing profile of the alignment. So that's how you can generate your output of horizontal and vertical alignment in AutoCAD Civil 3D by taking the data of DEM from Google Earth